Hi, I'm Craig Cooden, Editorial Assistant with Make. In today's weekend project, we'll be building a remote alarm system that uses your cell network to send text messages when it picks up an event. It can detect movement, contact, proximity, and changes in ambient light, and it's easy to modify with other kinds of sensors for your own custom applications. It was designed and built by Adam Wolf of Wayne & Lane, and we call it the Cellular Sensor Sentinel. You'll need these parts to complete the project. Head over to your local Radio Shack, where you can pick up most of the components needed for the build. You'll also need these basic tools. We'll show you how to connect 4 simple sensors to detect different events. A simple homemade contact sensor will respond to pressure, and an even simpler DIY capacitance sensor can sense the proximity of many objects, including people. An off-the-shelf passive infrared motion sensor picks up movement, and a basic light sensor will detect changes in ambient light levels. We'll start the project by building the contact sensor. Cut a long rectangle out of cardboard, and then cut and glue 2 smaller rectangles of aluminum foil to the cardboard as shown. Next, crease the cardboard in the middle and fold the foil-covered surfaces toward each other. Cut 2 sections of drinking straw and attach them across the foil on one side of the sensor by folding them around the back and securing the 2 ends with tape. Now, attach alligator clips to 2 opposing corners and cut out the adjacent corners so that the clips will not short across the gap when the sensor is folded over. Close the sensor and check its operation with the continuity tester on your multimeter. The straws hold the foil surfaces apart, but when something presses down on the middle, they make contact and close the circuit. Now let's build the capacitive sensor. It works by detecting the change in capacitance, or the ability to hold an electric charge, of a metal film when it comes in proximity with another object. To build the sensor, cut a rectangle out of cardboard and cover one side with aluminum foil. Next, attach an alligator clip to the foil. That's it. Seriously, that's it. Now let's build a battery pack to make the project mobile. Simply solder a power connector to the battery pack wires and reattach its sleeve. Now all you have to do is fill it with AA batteries and it's ready to power your Arduino. If you haven't already, visit the project page for links to the Arduino software, appropriate libraries, and example code. Upload the code, open the serial monitor, and set the baud rate to 115200. You should see Hello World appear in the serial monitor window. Now it's time to add the GSM. Start by installing your SIM card, connecting the antenna, and setting 2 jumpers to software serial. Now plug the shield into your Arduino and power it up via the USB plug. Open the serial monitor and set the baud rate to 115200. You should see the green LED light up on the board, and the serial monitor should print ready. Now it's time to wire up the sensors. Start by plugging in the PIR motion sensor into the shield, with the output connected to pin 2, VCC connected to pin 3, and ground connected to pin 4. Next, add the light sensor by connecting the short leg to ground and the long leg to A0. Now connect one of the contact switch alligator clips to the ground leg of the light sensor, and the other alligator clip to a small piece of wire inserted into pin 10. Connect the capacitive sensor last. Add a 10 mega ohm resistor between pins 11 and 12 and attach the alligator clip from the sensor to the resistor lead at pin 12. That's it! All 4 sensors are ready to go. Before we can deploy the project, we need to do some testing. Because this project sends text messages, and text messages can cost you money, texting is disabled by default. We can test the sensors with texting disabled because the Arduino will print to the serial monitor when it would have sent a text. Open the Arduino serial monitor with the baud rate set to 115200. You should be able to see a Hello World message shortly followed by the GSM shield turning on. Put your hand in front of the PIR sensor and verify that the serial monitor reports the correct event. Next, press and release the contact sensor. You should see a press event and a release event on the serial monitor. The capacitive sensor needs a little configuration. First, it probably won't work well on battery power, so if you're using batteries, set cap sensor enabled to false. Otherwise, you need to set the lower and upper thresholds in the code. The raw sensor value will print to the screen a few times a second. Watch the numbers as you put your hand closer and further away from the sensor and set the high and low thresholds accordingly. The last step is to test the cellular functionality. Set SMS number to a valid outgoing phone number. You'll also need to replace the default phone number with the number of the phone you want to receive the texts when the Sensor Sentinel is activated. Confirm that min ms between SMS is relatively high. How high? Let's start with at least 30,000 milliseconds, which is 30 seconds. This will prevent a potentially expensive flurry of text messages if something goes wrong with the sensors. Finally, set SMS enabled and send SMS at startup to true to enable texting. Then re-upload the code to your Arduino. Now you can test the whole system. Power everything up and open the serial monitor. The shield should send a text message. Keep an eye on the serial monitor window for error reports. After 30 seconds or so, unplug the Arduino and wait for the SMS to come through on the outgoing number. It shouldn't take too long, though delivery time will vary with network congestion. The text message will contain the trigger reason, the state of all the sensors, and the time it was sent. Once the text message arrives successfully, you'll be ready to deploy. You can use the battery pack, a wall wart, or the USB cable to power the sensor Sentinel. Place the sensor Sentinel near your garbage can to detect and text you when your pup is being a rascal. Put it inside of your birdhouse to sense and notify you when that rare bird is back and ready for you to snap that award-winning photo. The cellular sensor Sentinel is designed to be versatile. You can easily add more sensors to detect humidity, barometric pressure, magnetic fields, acceleration, vibration, flexing, tilt, or almost anything you can imagine. Be sure to check out the project page for ideas on additional hacks and modifications. And it's also a great place to ask questions and share your own build.